Hello and welcome back to Compiler Programming. In last week or so, I've been cleaning up a lot of things with the argument passing and different color conventions and all kinds of things. And the issues I started to run into were quite gnarly to figure out. And the fact that debugger does not correctly show things like sum types or custom types or arrays that I create is not really helping. So at first I thought, well, I guess I just gonna have to go in and add all of these types here. So as you can see, I already have a file with extension .natvis, which stands for native visualizers, which is the format that Visual Studio uses to describe sort of an extra formatting for debugger, so that debugger knows how to print custom types. If we, for example, go here, launch our program, and look at something like source range, which I have a custom type for, you will see that here we have args range, and as you can see, it shows me the string, even though the actual object contains a file and a range of bytes in that file. But I'm doing the calculation here for the string, and this is what I get to see, which is very, very handy because now I can look at the source range as a string instead of trying to figure out where it is actually in the file. But besides these very custom ones, where I do have to actually write them by hand, there is just stuff like this, where you have tagged union type, and depending on that tagged union type, I basically select what to display. This is a pretty standard thing, but unfortunately, this is not something that exists in C or C++, and that in turn means that debugger doesn't know how to display these kinds of types. So we have to write it yourselves. But then realize that actually I already have all the information, right? All the types are generated through this meta.c program. So maybe what we could do today is use this infrastructure to also generate these native visualizers, at least for unions and for arrays, because debugger also doesn't know what to do with its arrays, as C doesn't really have standard dynamic arrays. So that's the plan, and I guess we can start working on that. So we go here, we already have two files. One is the type information, then we have the exports for the mass bindings, so that I can use these types inside of kind of programs in my own programming language. And now we will have generated natvis. Great. Unlike the other files, this is not a C header, this is XML, and I'm not gonna use any kind of XML builder or anything. I'm just gonna do string concatenation. The only real problem that we'll run into is maybe escaping less than and greater than characters and ampersand, but I don't think that is actually gonna be a big problem. So this is the header, and auto visualizer is the end. So let's make that work, I guess. I will need to escape a few quotes here and there. Okay. We'll get another file, print here, like so. More quotes to escape. Right, and we also need a few /n's in here. And finally, at the end, when we are doing this, we just do /auto visualizer. Okay, it needs this one, and we say MSVC native visualizers generated and file name. And that seems great. We don't need this kind of stuff. And we basically go through each type, and we would say print native. I would say just print natvis. Okay, so that is fine. Print scope. We'll put it here, static void, as all the other ones, because they just print to the file. And actually, I think, yeah, it gets a type. So maybe what we should do is get all of these copied and then figure out what needs to be done. Okay, and for now, I'm just gonna remove all of this stuff. And tagged union is gonna be the most interesting one, but I think that's not actually the one we're gonna start with. Instead, we are going to start here. Yeah, this is like this. So for number literal, we don't need to do anything because this is just something that prints a define macro in C. For functions, I also don't think we need to do anything. They are printed pretty well in debugger by default. So this is fine. For hash maps, this is going to be pretty tricky. I'm not sure I'm going to do it today, but we'll see. For now, let's focus on all the other stuff. And in particular, you should be able to see that, where is this array? Nope. Yeah, so here for structs, we actually generate an array type, and we also generate a pointer type here, and there is even a constant pointer type. We probably, I'm not sure if I want to put all of them here, but I guess, I mean, why not? Okay, so let's get this over with and put it here. So enums don't contain anything special, I guess, either. So they go into here as well. And we say nothing to do to make sure that we didn't forget about it, but it is something that we're not interested in doing. And now it is time to go for this stuff. Okay, we'll start with just a regular array type, and then we will go with pointer and const pointer. So this is what we need to print. And let's get this started. So like so, actually like so. Okay, missed one for the type. Okay, array items, fine. We need to escape, oops, a few quotes here. Here. And I guess that is about that. The only thing is we need to do %s in here and put the type struct name. Let's try to build this and see what is going to happen. Well, it at least didn't crash or anything, so that is pretty good. Now we need to put this over here, and this also should go into here. Yep. Right, so I'm missing /n. Let me quickly fix that while I notice that. So /n, 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 and more new lines. It's very unfortunate that, as far as I can tell, at least in these kind of files, it's not possible to have like a star here. I can't just say match any type. It supports type parameters for C++, but you can't just do sort of generic matching for C files, which is a bit unfortunate. Let me make this less indented. Yeah, maybe like so. Okay, much better. We have visualizer, we have type, and we have a bunch of arrays. And it's gonna be way more of them. So as you can see, doing it by hand would be quite annoying, but now we can do that. And also means that I can remove all the array types from here. And this file will now contain only custom types. So value view is a custom type, and source range is a custom type instruction here. And for now, we'll keep storage as well. But what I'm interested in is if we can look up some of the arrays. But this is a pointer array. Well, let's just do pointer arrays right away as well, and then we will go from there. So what I can do is I can do const char star suffixes, and this is going to be like this, and suffix is nothing, then suffix is pointer, and then is it const pointer? Is it how it is? So I guess not. This is quite unfortunate that this is underscore const. I guess I'm gonna do it differently. I'm going to say print natvis array, and then here's gonna be const char star name, and then it's like so. This will get the name, and it will actually include, yeah, like this is fine. Now I can take this buffer here, and we're gonna use this buffer like name buffer maybe for a better version. Right, %s, so it's gonna be array. No, we don't need array. So I can do, so I print an array like this. Maybe I want even another abstraction. Array types. Right. So at first I'm just calling it with the name itself. Then I'm going to do it with the pointer. call it like that. And that is array name buffer. Yep. And then I'm also going to do the same, but now with const pointer. That sounds about right. And so here it's actually going to be struct name. That is done. And let's see how we are with this. Not too good. Right, I'm missing a file argument. Here now we need to do it like this. Yeah, and also I of course need to pass a file here. Okay, that builds. If we look at our generated natvis, now we have way more stuff. We have regular array, we have pointer, and we have const pointer. That is a lot of stuff, but since we generated, I don't really care that it is a lot of stuff. Good. We can now stop here again and see if our debugging information actually works. So we have args, and yeah, it does. And so as you can see, it is treated as an array. It shows the length of that array, which is this field right here, and it also shows elements. Right now we only have one element, and then we can go and look into raw object structure, which is, you can see, quite a bit different from what we see in the debugger by default. So this is very, very nice. I have no idea what these are, to be honest, and why they show up like this, but that is something else for me to consider. Okay, that is good progress. We can save this stuff, and let's go on and also do the same thing for the unions. Right, now we have unions, which is great. And for the unions, we need to do more stuff. The basic idea is that for the union, if it has extra fields, then we show them. Otherwise, we just show the name of the variant that is there. And finally, if none of the variants match, we should basically say that it's an invalid tag or something like this. As the template, I can try to go here. Of course, this is a custom representation, but I think even if we have something default, that is still pretty good. Okay, so we can probably take the structure from here. Right, type name, union name, that is good. %s, yep. And then we have display storage, or display string, sorry. Display string, condition tag, yep. It's definitely %s. This is %s, %s. So this is the name of the type, and this is the name of the sort of variant of the type. And here is what we are going to show, I guess. Maybe it is worth for me to split this into two parts, because what is inside of here will actually vary between different types. So something like that. Let's comment this stuff out. And I guess copy the setup. Oops. Somehow I didn't copy all that I wanted. Like so. So we need to iterate over all the variants of the union. We get each of the ones, and this checks again if this particular variant has fields or not. Maybe it just has a tag. For example, in here, if we have storage tag none, it doesn't actually have any field because there is nothing to talk about. But some of them do. So, but regardless of whether we have something to show or not, we still need to have this as a display string, and that would be well, basically something like this, I guess. So we have union name and struct name. Yeah, that seems about right. And then what do we do? Well, if there are no counts, then I think I'm just interested in printing the name of the name of the struct, or the name of the variant to be precise. I think we can build it like that. At least it will check all the other stuff. And if we go to generate it, let's look for storage. Yep. So that's pretty good. As you can see now, if we have none, then we just show none. If we have any, we just show any. And then for the ones that actually have fields, this is where we will figure out what we need to show. I'm not exactly sure that's the best way to go about this, but so expand does not have specifies a single child element. It only accepts complex type. Well, child node itself can be expanded by the user. And what is synthetic? Okay. I'm just thinking whether I want to have something specific for the expansion or just display string. Okay, we'll just stick to display string, and then I will think later if that's if I want something else. For now, I just wanted to sort of demonstrate the whole setup and have some skeleton for me to start refining it later on. Okay, so here we still probably want to show the name of the type, and then we will show one of the union fields, and then we will see how does it look like. I guess we can do it like this. So this will be the name of the variant, and then we need to access the field in the struct, or the field in the union, that is also conveniently named the same as the name of the variant. So something like so. I'm not sure what that will do in a debugger, because this is can be a complex type, but I guess we'll see what happens. Yes. Okay. So that is something good. Let's add a new line. Okay. That seems fine. Let's try to see what that will result in. And I guess I need to now remove the storage from here. Otherwise, we will have conflicts. And instruction as well, because it's a union type. Okay, that builds, and where can I look at the storage? So storage, base storage sounds great. Whoops. Let's do it here. Great. Well, that's not too bad, to be honest. That's kind of what I wanted. As you can see, we see the variant of the type, and then we see the fields, because that's how the types are serialized. Now, what I was thinking about is connected to this expansion, right? I still can see here the fields that I don't want. For example, I don't want the padding field, and I just want to see one of these that is the right one. So I think I can do it with the expand stuff, but I guess we'll see. Let me add it to the Git index, and then we can try to figure out with expand. So how would that look like? This is only, actually no, it doesn't depend. Yeah, no, it does. If we one thing I need to do is I need to output common types or common fields for the type. I guess it is this stuff. So first of all, we need to have this expand node. Expand. And expand, actually, then it's a separate from display string. Okay. And wait a second. Expand needs to be on the level of the type. Right. Okay. So that means it actually needs to go in here. For each of the common things, we need to have one of these. This is %s and %s. How does that look like? You are unhappy about expand because it needs to be like this. Okay, now you are happy. Let's see what that looks like. Okay, we have base storage. Great. So now we can see only the one that we want. Cool. I think I do want to see the tag field always, so we can just say tag, and besides that we also copy this loop that is for the variants. I guess I want common fields first, and then for the variants, basically, yeah, if we have custom fields, then I will do the following. So this goes away, this goes away, and we need the condition here. Item name, yeah, condition, tag, right. So that's quite a complicated thing, but I think we just need to do this. I guess I want to get this on the new line. So first, actually no. So first is struct name. Then we have type union name, struct name, and then we have another struct name. I think that is what I want. All right, that is not a display string. We don't need that. Okay. Right, so I show eflags field if the tag is eflags. I show register field if storage tag is register. That seems what I want. Let's see if debugger agrees with me. And here we have page storage. We expand it, and look at that. We have only a single thing here, which is register. I don't really need to expand it because it is nicely shown anyway. But if we have something more complicated, so if I step over this and we look at pointee storage, that is in memory, and then I have location, indirect, and this is also a tagged union, right? So that's why I see it with a tag and this thing here. I think this is pretty nice. I could figure out how to skip paddings, but I'm not gonna worry about that too much. I'm okay skipping them visually for now. Cool, so that is basically what I wanted to do. There is now a bunch of generated native visualizers. Maybe there are other things I could generate. Maybe I could generate a custom one, but even just having this kind of stuff auto-generated is pretty nice, and now I think debugging will be much better for me. I guess that's all. Thank you very much for watching. I hope it was useful, and I hope to see you next time.